have for parallelogram? Look at your notes. What was one option? Distance of all four sides. What's in the second option? Slopes of all four sides. I don't know why you couldn't do this, sir. You're answering all my questions. What was the third option? What was the third option? And that was one of the ones on your test. If one pair of opposite sides are both parallel and equal. One pair parallel and equal. And that's what I'm going to go for. One pair parallel and equal. It's got to be the same pair. Now, when we're dealing in a horizontal segment, then you don't have to do the distance formula. You literally can say AB is equal to the absolute value. This x value is 4, and that x value is 0. Do you agree it is 4 units? You can count it. 1, 2, 3, 4. Do you see that? If I did the slanted one, would I need distance formula? Yes. All right, so now let's look at CD. This is why I'm picking these two sides. CD, I'm going to say negative absolute value of -3 minus -7. That's going to be plus positive. That's going to be 4. Are these sides congruent? Yes. Now I have to see if these sides are parallel. So now I'm going to do the slope of AB. The slope of AB is going to be 2 subtract 2 over 4 minus 0, or 0 over 4, which is 0. And I'm going to do the slope of CD. Slope of CD is going to be -4 minus -4 over -3 minus -7. I need to do plus positive. That's going to be 0 over 4, which is 0. Are the slopes equal? So AB is congruent to CD. We also know that AB is parallel to CD. So is this a parallelogram? Yes. Why? Because one pair of sides are both parallel and congruent. Next question. 18. All right, 18, you needed to graph. So this section was on coordinate geometry, and it was for all figures. This appears like three things. It must be a triangle. So we've got -5, 2, 4, 5, 0. This is J. This is 18. Then we're going to do 5, 2, 4, 5, 2, 4, 6, 8. This is K. This is going to be 5, 8. Then we have L, which is 1, 2, 3, 4, -1. And J was -5, 0. All right, did I plot these points correctly? Yes or no? Okay, so they want to know, is it scaling, isosceles, or equilateral? What are we going to have to do to figure this out? Measure each side. That's a distance formula. They're all slanted, which means we definitely need the distance formula. So JK is going to be the square root of 8. So how about 5 minus -5 squared plus 8 minus 0 squared. This is going to be the square root of plus a positive. How about 10 squared plus 8 squared, which is the square root of 100 plus 64, which is the square root of 164. That's JK. So now we're going to do KL. KL is going to be 5 minus 4 squared plus 8 minus -1 squared. 5 minus 4 is 1 squared. 8 minus a -1 is 9 squared. So that's going to be 1 plus 81, or square root of 82. Is it equilateral? No. We already know it's not equilateral. Third side is JL. So we're going to say 4 minus negative 5 squared plus negative 1 minus 0 squared. This is going to be plus positive, so that's going to be 9 squared plus negative 1 squared is going to be 81 plus 1, or square root of 82. What type of triangle is it? It is isosceles. Why? Because JL is congruent to KL. Next question.
Would that also make it a right triangle?
They didn't ask us about right. What would, oh, tell whether it's a right triangle. If it's a right triangle, where would the right angle be? At L. How do we figure out if that is a right angle? What do you need to do? Okay, how would we do Pythagorean theorem? Well, we would say legs squared, right? Plus legs squared. Now, why am I picking the square roots of 82 to be the legs? What should be the largest? Right, that should be your longest segment. What happens when you square a square root? 84. What's the square root of squared? 82. And this is 80. Does this is the question, does it equal 164? 164 equals 164. It is a right isosceles triangle. What else could we have done if we didn't want to do Pythagorean theorem? What's the other option? What do you know about slopes of perpendicular lines? Jeff? Opposite reciprocal. So could we have done the slope? Could we have done the slope of JL and said that that's negative 1 minus 0 over 4 minus a minus 5, or get negative 1/9, and then do the slope of KL, which is going to be 8 minus a minus 1 over 5 minus 4, which is going to be 9 over 1. Does that tell me that they're perpendicular? So there's another option. Caitlin? All right. The beauty about graphing these is it will help you narrow in on what you need to do. So we have our coordinate plane. We're going to graph 1, 2. That means we go to the right 1 up 2. That's L. 1, 2. Then we're going to do 3, 3. 1, 2, 3, 1, 2, 3. That is M. And that's 3, 3. Then we're going to do 5, 2. 5 up 2. And that's N. I don't know which direction we're going here. And then we have 3, 1. And that happens to be P. Did I graph those right? No. This should be 5, 2, and I did 6, 2. All right, so we're going to connect the dots. Now, you have to determine if it's a rectangle, rhombus, or square. So what does it look like? It looks like a rhombus. Is it a rectangle? Okay, rectangle has to have what kind of angles? Right angles. Are any of these angles right angles? No. All right, what do we know about the diagonals of a rhombus? Okay, that's a parallelogram. Okay, but there's no way we can figure out angles on the coordinate plane. What else? What else? Give me more. Look at your notes. What are your options for a rhombus? Perpendicular what? Okay, if we want to show that the diagonals are perpendicular, what do we need? Distance, midpoint, or slope? Slope. So now we're going to find the slope of the diagonals. So we're going to first find the slope of ln. Midpoint, just because the diagonals bisect each other just makes it a parallelogram. It doesn't make it a rhombus. Rhombus are perpendicular. So we're going to say 2 subtract 2 over 5 subtract 1, which is 0 over 4. Now I'm going to do the slope of MP. That's an MP. And that's going to be 1 minus 3 over 3 minus 3, which is going to be negative 2, 0. All right. When we have 0 involved, it's not important what this number is versus that number. Is 0 in opposite positions in the fraction, and is 1 positive and 1 negative? So that means that shows the perpendicular relationship because they are opposite reciprocals. So we know that L, M, and P is a rhombus because the diagonals are perpendicular. All right, so now we're going to switch gears. We're going to work in... No, because I got to teach. If I have time afterwards, we'll go back to it. I am here after school today. All right, so we're going to do perimeters and whatnot. Area covers, perimeter goes around. Put this in your notes. Area covers, carpeting, hardwood floors, porcelain tile. Perimeter goes around, baseboard molding. Let's see, decorative edging on a garden, fence in the yard. This is 10. These notes are 10, 1, 10, 2, and 1, 8. Area covers, perimeter goes around. Carpet. Hardwood floors. Grass, I think would help you. Perimeter would be, do you know what baseboard molding is? Okay, so I want you to look at this black stuff that's on the wall and rests on the carpet. That's baseboard molding. In your house, it's most likely wood, but you've got that around every room. That's what finishes off the wall and the whatever flooring, so you don't see the rough edge. If you do fence around your yard, if you do decorative bricks around a garden, that's perimeter. If you put fringe around the edge of your tablecloth, all of those are perimeter. Distance or area covers, perimeter goes around. So you're going to see a new formula for your rectangles and your squares, but this way I can minimize the number of formulas that you have to remember. All right. So if I wanted to find the area, I'm literally counting these blocks. 1, 2, 3, 4, 5, 6. And if there's a 6 in that row, then there's going to be 6 in this row, and there's going to be 6 in that row. So what is this area? 18. If I want to figure out, if I wanted to fence in this yard, this is 6 units, this is 3 units, this is 6 units, this is 3 units, and I would say 3 plus 6 plus 3 plus 6 is 18. Are you kidding me? Okay, is the area and perimeter always the same? Bad example. tried to come up with one. It would have taken me forever. All right. If you have to find the area of a figure that's like this, we've got 3, 6, 9 units here. So I'm counting squares. That's why they called square units. Bless you. Do you see this rectangle right here? Right there? That rectangle? How many units is that? 6. What did that do to the area of that rectangle? So what is this? 3. Okay, over here, if I look for this rectangle, what is that rectangle? 3. What did that diagonal do? So this is 1 and 1/2. So you'd have 9 plus 1 is 10, 11, 12, 13. So this would be 13.5. Now, if you wanted perimeter, what would you have to do to find that length and that length? Pardon? What would you have to do to find those lengths? Oh. How did we do it on the homework? How do we find slanted lengths? Distance formula, correct. All right, so we're going to move on. All right, now, I'm going to say this over and over and over and over again. The base and height in any geometric figure always has a perpendicular relationship. My question will be, what is the relationship between a base and a height? And Nick, you will tell me it is what? What is the relationship between a base and a height? Perpendicular. What's the relationship between a base and a height, Hope? What's the relationship between a base and a height? Kayla, E? What's the relationship? Perpendicular. What's the relationship between a base and a height? Kayla, S? Perpendicular. What's the relationship between a base and a height? Brittany Norwood? Perpendicular. You've got to know this. This makes everything from here on out for the rest of the content easy. Base of a geometric figure is the side of the figure that's perpendicular to the height. Height of a figure is a segment that extends from one side of a figure to the line containing the other side. Line containing the opposite side. This is the deal. Do you see that parallelogram? What is the relationship between any base and any height? What is it? Perpendicular. So in this figure, this is the base. This is the height because this relationship is what? Perpendicular. If we look at this figure, this would be the base right here. But where's the height? What's this relationship? Bree, what's this relationship? Perpendicular. Now, notice I could bring this segment out here. The height is a segment that extends from one side. Is it extending from the top? And is perpendicular to the line containing the opposite side. Notice this base stops here, but the line that contains it goes further, correct? So this is my base. This would still be my height. The height can fall outside the figure. Bottom line, what's the relationship between any base and height, Samantha? Perpendicular. Okay. Could we have said on this figure, could we have said that this side is the height? Yes, because that is perpendicular. But is that going to be true in every figure? No. So if we look at this, here is a line containing the opposite side. And if I wanted to do a perpendicular, does that look like it forms a right angle? If that's the right angle, then this would be my height, this would be my base, or that would be my base. All right. So let's look at your investigation. Who's got the investigations? I think I have them in here. All right. So we are going to look at, did I put them in here? Maybe not. 45. Ah. All right. So what we're going to do, and I don't know how much I have to do today, but I really wanted to do these explorations. So let me look at my notes. We're going to do rectangle. We're going to do parallelogram. We're going to do area of a triangle, area of a trapezoid, and then we're going to do it on the coordinate plane. Okay. So I'm going to stop the notes, and we're going to go to, well, let's go ahead and do the rectangle notes. The area of a rectangle is given by the formula area equals little b times little h. I do not want to see length times width. I want to see little b times little h, where a is area, b is the base, and h is the height. Okay? B is the base, h is the height. So if you wanted to find the area of this figure, what would it be? 24 times 6. The reason why is because this is the base and this is the height, because the relationship between any base and any height is what, Karen? Perpendicular. All right, so there's my right angle. This is 9 inches. This is 30. This is where I think it gets, geometry's the best. All right, so do you have either the base or the height in this figure? You do? What's the base? No, I'm talking about the next one down. This one. What's the base? What is the base in this figure? Well, it's going to be occurring at the right angle. So we know that that is the base and this is the height. Do I know either one of those?
30 for 30, 60, 90.
Opposite 30 is, opposite 60 is, opposite 90 is, and what equation do we write? 2x equals what? 9. What does x equal? Oh, what do we have to do? I wish. Right, which is 4.5. So that means this side is 4.5, and what is this side? How do we do x square root of 3 if x is 4.5? What are we going to have? 4.5 square root of 3. So this side is 4.5 square root of 3. So how are we going to find the area of this figure? Area equals base times height. What's the base? 4.5. So area equals, am I still recording or did I stop it? I'm still recording. Equals 4.5 times what? 4.5 square root of 3. What parts of these can we multiply? Okay, 4.5 is 9 halves. Times 9 halves is 81 fourths. So I turned it into fractions because I can do that without a calculator. See, I would have introduced the 30, 60, 90, 45, 45, 90 triangles a long time ago. And you would have had those in about every assignment if I got to arrange the curriculum. All right, let's look over here. Here's another one. What have you been given? We need the area, base times height. What have you been given? The height only, right? How are you going to find the base? Pythagorean theorem. We'll let that be B. So how do we do the Pythagorean theorem? 8 squared plus b squared equals 12 squared. So we're going to have 64 plus b squared equals 144. B squared is going to equal 80. What is b? Plus or minus square root of 8 times 10. What are the factors of 8? 2 times 4. What's the factors of 10? 2 and 5. How does that factor more? So this is going to be 2. What's 4? 2 times 2, and you already had that 2 and that 5. What was multiplied by itself? 2. What else was multiplied by itself? 2. So what is this going to be? 4 square root of 5. So that means that this is 4 square root of 5, because you're going to have part of your test is non-calculator.
What? This class?
An EOC. What's 8 times 4? 32 square root of, right. I'm loving it. Are you loving it?
I said it was going to be fun.
Oh, I think this is great. Oh, it is. Anytime we can bring back old stuff. What's a formula for the area of a rectangle, Jeff?
Base times height.
And what's the relationship between any base and height?
Perpendicular.
Thank you. All right. So now what you're going to do is we're going to get out and we're going to start the investigations. Yes. Let's go back.